Okay, this lesson is over finding arc measures. There's going to be a couple different ways that we measure these things and find them throughout the course of the chapter. Arc measures are just going to kind of help us find distances around the outside of the circle. It'll be pretty self-explanatory for the most part. Again, always ask questions if you have them. Make sure you take the notes. If you miss something, you may come back and re-listen to it. I know it might take a little time, but something I say may be of use. So make sure you go back once your notes are completed and listen to what's going on in the video. So our learning goals in this one, again, hopefully we'll be able to find arc measures, identify congruent arcs, and then prove circles are similar. We probably won't do too many proofs and things. I'll just show you kind of the proofs and how that works. So first of all, we have a couple different ways to do this, like I said, but the first way that we're going to find the measure of an arc is by starting at the center of the circle. So we have what's called the central angle, again, of a circle, is the angle whose vertex starts at the center. So if I have an angle that starts at the center and it's created by two radius in my circle, that's called a central angle. There's a couple different types of arcs that you're going to need to know the terms and the differences between them. First of all, a minor arc there, it says, is going to be on the interior of the triangle, and it has a measure less than 180 degrees. A major arc is going to be greater than 180 degrees, and you have to denote it with 3 letters rather than 2. And then a semicircle is going to also be equal to 180 degrees, again, also being 3 letters that you use to label them, okay? So again, copy down some of this, but you don't necessarily need everything. Just know the difference. Minor arc less than 180, major arc over, semicircle equal to, okay? So again here, the measure of an arc, you're going to see this notation here in your notes quite frequently, and as we progress forward through the chapter, it'll have that little M. So the measure of the little arc AB is 50 degrees. If we were asked to identify the measure of arc ADB, that's a major arc, and it goes the other way around the circle, so you always follow the letters in what order they are. So if I have to go from A to D to B, I have to go around the outside of the circle like you see there. Again, hopefully we all know that the entire measure of a circle is 360 degrees. So if I just take 360 minus 50, I get the measure of that arc at 310 degrees. Again, notice the notation. Make sure you make a note of that. When you have an arc, you have to make sure you use capital letters like we did with vertices, and you want that curved arc over the top of it. And that's for a minor arc. And if it's a major arc, again, capital letters, and you're telling the direction to measure when you go through D to B. So make sure you have those letters when you need them for a major arc. You should never have a major arc noted with 2 letters. It won't work that way. Okay, so finding the measures here, you guys, again, should be pretty straightforward. First of all, RS should be pretty easy. It's noted here. You can see that's 110. Again, it also asks us to identify whether it's minor, major, or whatever. This one's going to be a minor. Okay, RTS, so if I follow R to T to S, I have to go this way around my circle. Now again, we're going to have to use some of our reasoning skills here and see that this line cutting through P to R is a diameter. So that means that the distance around the outside of that is going to be 180 degrees. So if I take the 180 on either side, this side is 180, and then this whole other side is 180, so that makes this little part here 70. Now I can find the measure of RTS. I add 180 and 70. Okay, so when I add those up, just making sure I don't do my math wrong here, I get 250 degrees, and that would be a major arc. And then RST, so again, if I follow my letters, RST is this way, that's our semicircle. That's 180 degrees. So make sure to read the directions on stuff, because on your quiz, I believe I ask you for a degree and to state whether it's a minor or a major when we get there at the end of the week. Okay, the next thing we're looking at is arcs that have the same or shared parts. So two arcs of the same circle are called adjacent when they intersect at exactly one point. You can measure two adjacent arcs by adding them up. So again, it shouldn't be too unfamiliar to us that if I know this arc here and I know this arc here, I should be able to add those up to find the measure of arc ACB if I need to. So that's all that postulate's saying. It should be pretty self-explanatory. So in example 2, again, we're missing parts of it, and we don't necessarily have a semicircle anywhere because, as you can see, from R to H, it does not look like it's straight in line with F to R. So this is not a diameter here, and you can also clearly see that by the measure of these angles here. So this is 110 and this is 80. That means it's not a straight 180-degree semicircle. However, I do know the total of the circle has to be 360. So if I subtract 360, or if I subtract all of these degrees that I know from 360, I should be able to find my missing piece that will kind of help me complete the puzzle here. So once I have identified that that is 130 degrees, now I can go through and answer these questions. So from G to E, again, they're talking about the minor arc because they only use 2 letters, so we're going this way. From G to E, if I add up 40 and 80, I get 120 degrees. And again, that's a minor. Okay, from G to E to F, now again, we have to follow the order of the letters. From G to E to F, I have to add those all up. So I have 120 plus 110, and I get 230. Whoops. Let's select my writing tool there. So 230, that would be a major arc. And then the last one from G to F, we have it solved out there for us, is 130. And again, that's a minor. Okay, so we just add those up. Okay, again, finding arc measures in pie graphs. This is something kind of real life application here where you're doing surveys. If you ever want to conduct a survey and display it as a pie graph, you obviously want to take your sample space and set it equal to your full 360 degrees. And then for every chunk of your data, you want to divide that by 360 to see what percentage or what angle you want to use. Now, for this one, it's just asking the arc measures of the indicated. So on the first one, it's A to C, so I take 108 plus 29. So on the first one, I get 137 degrees. Okay, ACD, again, following the order of the letters from A to C to D, that way we would have to do 29 plus 108 plus 83. And when we do that, we get 220. ADC, now again, it's the same letters, but we went the other way. So now we're going around our circle this way. So we do 79 plus 61 plus 83, and we get 223. And then the last one, EBD. So if I follow the arcs, we essentially go E to B to D. So we went all the way around the circle except for this chunk. So on this one, what I'm going to do, instead of adding those all up, is I'm just going to take 360 minus 61, and I can get that much quicker, and that's 299. Okay, so again, you can add and subtract based on what you know and what your missing information is, but you should be able to just add up the measure of those arcs there. Pretty straightforward. So again, here's our first monitoring progress. I'll be checking for these 6 in your notes. Make sure you take the time to pause the videos, but we have 1 through 6 here that I'd like you to go ahead and answer. Again, make sure you identify minor, major, or semicircle on these because you'll be asked to do that on your quiz as well. Okay, so the last piece today is identifying congruent arcs. So first of all, in order for you to have congruent arcs in 2 separate circles, you have to know that the circles themselves are congruent first. Okay, so this theorem here is talking about congruent circles, and it's saying the only way for 2 circles to be congruent is if their 2 radius that creates them are congruent. Because again, the definition of a circle is all points that are equidistant from a center. So if our 2 circles aren't congruent, the arcs can't be congruent inside of them when we have the same angle measure. So there's a couple different cases here. First of all, congruent arcs, again, inside the same circle should be pretty easy to identify. A lot of times they're going to be created by vertical angles. So if we have these two diameters that are constructed, we know that the angles that are on the inside of these circles are congruent. That means the arcs that they form have to also be congruent and vice versa. So again, that's why you have this if and only if statement, because if these angles are congruent, then the arcs are congruent. And on the flip side of that, if the arcs are congruent, then we know these angles have to be congruent. So when you see this if and only if statement, if and only if, it means these things are working both ways, not just one way. Okay, so in these circles, again, the first two, it should be pretty easy to tell whether or not we have congruent arcs. The number one, you have the same circle and you have two 80-degree angles, and it's saying, okay, if I have 80-degree angles, are those arcs congruent that are on the outside? This one's going to have to be yes. It's inside the same circle. It's both created from that central angle there. They're both 80 degrees. We're good to go. Now, this one's trying to be a little tricky. While it's created by the same central angle, the circles themselves are not congruent. You can clearly see that the small circle on the inside should not have the same length as the arc of the big circle on the outside. So this one's no, because your circles aren't congruent. Okay, your circles aren't congruent. Letter C, our circles are marked congruent by the radius having the congruence marking on it, and we have the same degree from the central angle. So yes, those are going to be congruent because it satisfies the theorem. So yes, congruent. And that's, again, the theorem that we just wrote down. So again, make sure you explain why or why not, but the last two we have in this section are just tell whether or not these circles have congruent arcs and explain why or why not. Make sure, again, if it's the theorem, you can say the circles are congruent, the arcs that are created by the same central angle are congruent, or we can just use that fun theorem number right there, good old 10.4 or 10.3, depending on which one you need to use. So theorem number is perfectly sufficient. Okay, so again, there's our last two monitoring progress. Make sure you add those to your notes. Not a super long lesson today, guys, so let's make sure we're being productive with our time in class. We have our summary is there's our 3 learning goals that we are supposed to be able to do. And then we have our assignment posted to Big Ideas. Again, always make sure we ask questions. Make sure that before we refer to having someone help us out, we refer to our notes and we know how to use them productively. Thanks, guys. Have a great day.